In this video, we're going to look at balancing equations from the words. Then we're going to go to the chemical formulas, and then we're going to go to balancing them. So if we look at this, aluminum, probably the first thing that's going to help us in doing this is we need to write the oxidation number, or the charges, over each one of the elements. So aluminum is a plus 3 charge. Bromine has a -1 charge. Bromide is the negative ion of the element bromine, which has a -1 charge. But here, you'll notice that the +3 and the -1 do not cancel one another out. So in this case, what we have to do is we have to switch these numbers. So I'm going to bring the 3 over here, and I'm going to bring the 1 over here. So once we bring these numbers down, I don't really have to worry about this -1, because these numbers are basically telling me how many atoms of each one of the elements that I have. So in that case, I'll go ahead and write what aluminum is. Aluminum is Al. This one tells me I've got 1 aluminum, but I don't really have to put the 1 because it's just understood. And bromine is Br, and this 3 goes with the bromine. So we have AlBr3, which is aluminum bromide. So we have and chlorine. So I'm going to put plus Cl. But chlorine is a little special because it's a diatomic molecule. What that means is chlorine is either bound with something else or it's bound with itself. And here it just says chlorine, so that tells you it's not bound with anything else. So it must be bound to another chlorine, which is Cl2. Um, react to form aluminum chloride. So react to form, that basically just means my arrow, my yield. So they do react to form these two. So once again, let's put the oxidation numbers over these. So aluminum, we've said before, is a +3, and chlorine is a -1. So just like bromide over here, chloride is the negative ion of chlorine, and these numbers don't cancel out like they are. So let's just go ahead and switch these numbers again. So 1 goes here and a 3 goes here. Remember, you don't have to bring the 1 over because we're counting number of elements. So aluminum is Al, and chlorine is Cl. So, but the 3 goes on the chlorine, so we have AlCl3, and bromine. Now once again, bromine, we're going to put Br, and because it's not with anything, let's try this, Br. And bromine, because it's not with anything, we don't have to worry about a charge, but it is diatomic just like chlorine is, so I'm going to have to put a 2 on this. Okay, so now that we've got our equation written out, now we have to go through and balance it. So whatever's on the left has to be equal to what's on the right. So if I look at this side, I've got 1 aluminum on the left, I've got 1 aluminum on the right. So they're even, I don't have to worry about them. So the next thing I'll go to is my bromine. I've got 3 bromines here on the left, and I've got 2 bromines on the right. So in order to balance these out, one thing I think is kind of useful to think of is what number will 2 and 3 both go into evenly, the smallest number. Well, that number is going to be 6, and in order to get 6, if I put a 2 in front of the AlBr3, this 2 multiplied by 3 will give me 6 bromines. Okay, so now if I go over here and I put a 3 in front of this 3 multiplied by this 2 will give me 6 bromines. So now the bromines are even. So now let's double check and look at my chlorines. So my chlorines, I've got 3 chlorines here, and I've got 2 chlorines here. So the same trick we just did with the bromine, let's employ that with the chlorine. So I'm going to put a 3 in front of my chlorine, and I'm going to put a 2 in front of my AlCl3. So now 2 times 3 chlorines on the right will give me 6 total chlorines on the right, and 2 times 3 will give me 6 total chlorines on the left. So now let's double check my aluminums. I've got 2 aluminums on the left, I've got 2 aluminums on the right. So this is the balanced equation for this particular reaction. So let's move on down and let's do another one. So this next one says hydrogen and nitrogen monoxide react to form water and nitrogen. So here, once again, hydrogen is not with anything. I know this says and, but this and means basically plus. So hydrogen is by itself, so I don't really have to worry about a charge. So I can go ahead and say H for that. But hydrogen is like bromine and chlorine from the previous example. It is a diatomic molecule, which means that it's either bound with something or another hydrogen. So I'm going to put H2 for hydrogen. And sometimes you may see this say hydrogen gas, or sometimes you may just see it say hydrogen. But anyhow, it means the same thing. So hydrogen and nitrogen monoxide. So here is a different example. We don't really have to worry about charges for this because this is a covalent molecule. There are two different ways we know that this is covalent. Number one, we can look at this mono. Anytime you see prefixes like mono, di, tri, that's a pretty good indicator that it's going to be a covalent compound or covalent molecule, and you don't really have to worry about charges per se when you're doing these. So nitrogen monoxide, there's just one nitrogen. Even though there's just one nitrogen, I don't say mononitrogen because the general naming convention is mono never goes first. So it's just nitrogen, which is one N, and monoxide, which would mean one oxygen, so just NO. So that's what nitrogen monoxide is. So hydrogen and nitrogen monoxide react to form water. So there's that react to form. So that means our arrow again, to form water and nitrogen. So water we know is H2O. So let's go ahead and write that. And that means plus nitrogen. So once again, nitrogen is a diatomic molecule, a lot like the hydrogen was here. It's not bound with anything else, so I don't really have to worry about a charge, but it can't be just a nitrogen atom by itself. I've got to have an N2 also. Okay, so now this is the chemical formulas written out. Now let's take a look and try to balance these. Alright, so if we start on the left, I'm going to start with, let's start with nitrogen. I typically like to leave oxygen and hydrogens till last, and oxygen usually till very last. But anyhow, so I've got one nitrogen here on the left, and I've got two nitrogens on the right. So if I put a coefficient of 2 in front of this, this 2 is going to give me two nitrogens on the left, and I've got two nitrogens on the right. So that fixes my problem with nitrogen. So now I'm going to look at my hydrogen. I've got two hydrogens on the left here. I've got two hydrogens on the right here. So they're fine. I don't need to worry about them. So now let's look at oxygen. Oxygen always seems to be the difficult one to work with. That's why we normally leave it till last. So if you've got 2 times this, there's an understood 1 to be right here. So I've got two oxygens on the left. I've got one oxygen on the right. Okay, so I need two oxygens on the right. So I'm going to go ahead and put a big 2 in front of the H2O. So now what this is going to do, I'm going to have two oxygens on the right, but now I've kind of messed up my numbers with hydrogens. I've got 4 hydrogens on the right and only 2 hydrogens on the left. But I can easily fix this problem by just putting a 2 in front of that. So now I have 4 hydrogens on the left, 4 hydrogens on the right. I have 2 nitrogens on the left, 2 nitrogens on the right, and I have 2 oxygens on the left and 2 oxygens on the right. So now this is a balanced equation for this one. So let's move down and do one more example for this video. This one actually involves a transition metal. If we look at this, zinc is just a metal. It is a transition metal, but zinc is by itself, so we can just put Zn. Zinc and lead nitrate. So let's just go ahead and put our plus. Now this 2 here means that lead has a positive 2 charge. Now lead is not exactly in the transition metal area of the periodic table, but it does take on multiple charges and it's treated like a transition metal. So this 2 means positive 2 for the lead, and nitrate, the charge on nitrate is -1. So here they don't cancel out like they are, so my lead is Pb. The 1 would go with the lead if I were to bring it down. I'm not going to draw it this time, but the 1 would go with the lead, and the 2 would go with the nitrate. So nitrate is NO3, and I would put parentheses around it because my 2 goes on the nitrate. I need to show that I have two nitrates, and this is the way you do it, by putting parentheses around it. Okay, so I've got zinc and lead nitrate react to form, so that's going to be my arrow, react to form zinc nitrate. So in this particular example, zinc has a charge of +2, and nitrate has a charge of -1. Okay, so zinc nitrate, the same thing here. They don't cancel out like they are. So zinc nitrate is going to be Zn NO3, and that needs to be in parentheses also. And the last thing we have is and lead. So if we look at this, that's Pb. All right. So this is our equation from the words. Now let's double check and make sure that it is balanced. I've got one zinc here on the left. I've got one zinc on the right. All right, so that's good. I've got one lead on the left, one lead on the right. You can look at this as individual elements, but you can also look at this as a whole polyatomic ion. You can either say I have two nitrates, which NO3 is nitrate. I have two nitrates on the left, and I have two nitrates on the right, or you could look at it individually and say I have 6 oxygens here, and I have 2 nitrogens, which you're going to get the same thing over here. You've got 6 oxygens on the right and 2 nitrogens also on the right. So this is actually already balanced as it is, and it's happy, and we don't need to do anything to it. And that's it for this balancing.